Hello, it's John Cheek here. I'm the founder of UniTasterDays, and a big welcome to this UniTaster On Demand event today, where we're going to be exploring university courses in chemistry. I am absolutely delighted to be joined by Dr. Natalie Capel, joining us from Keele University. Natalie is a lecturer in chemistry and is going to provide a guide to why you might want to consider studying chemistry, what to expect on the course, application tips and careers. And with that, I'll pass things over to Dr. Natalie Capel, joining us from Keele University.
Hello, my name is Dr. Natalie Capel. I'm a lecturer in chemistry at Keele University, as John just said, and I'm here to talk to you all about chemistry and why you should consider studying it at university. So why study chemistry? Well, chemistry is the largest manufacturing GDP exporter of the UK, with an annual turnover of over £40 billion and over 200,000 employees. This is because chemistry can provide the answers to many of today's societal challenges. The government's industrial strategy sets out grand challenges to put the UK at the forefront of industries of the future, ensuring that the UK takes advantage of major global challenges, improving people's lives and the country's productivity. The first four grand challenges proposed by the government are focused on the global trends which will transform our future. These are artificial intelligence and data, the ageing society, clean growth, and the future of mobility. So how does chemistry and a chemistry degree fit into these? Artificial intelligence has been used for many years now to accelerate drug discovery and reduce its huge costs and the time to market for new drugs. It does this by applying machine learning algorithms to virtual drug analog screening, physicochemical and pharmacokinetic property prediction, and drug repurposing. The image on the right shows drug docking software that predicts the binding and therefore efficacy of new drug analogues. The applications of AI in chemistry are not limited to just drug discovery, though. It can also be used to boost productivity in laboratories by running computational models that can predict optimized reactants and conditions to achieve the best possible throughput, or even the most environmentally friendly or energy efficient reactions. Improving the environmental efficiency of chemical processes is key to a greener society, and is one way that our graduate chemists can make a huge difference to society. Improved quality of living with a continually growing net population is creating an enormous shift in global demographics, with many countries facing a dramatic increase in their percentage of elderly citizens. In fact, the United Nations has predicted a 56% increase in the 60 years plus age bracket between 2015 and 2030. Whilst extended lifespans offer a wealth of opportunities for the individual and society, they place an unprecedented demand on global healthcare systems. As age-related diseases rise in accordance with our ageing population, novel and more efficient therapies are required to treat them. Pharmaceutical innovation is critical to delivering these new treatments, and the latest advances in nanotechnology and AI offer particularly promising prospects to this great unmet medical need. The image here shows the Alzheimer's drug galantamine bound to its target enzyme acetylcholinesterase. You can see the drug molecule there, here, here, here. Acetylcholinesterase is an enzyme which ties the neurotransmitter acetylcholine body, and inhibiting this enzyme increases the availability of the neurotransmitter, which is Alzheimer's. Graduates progressing into medicinal chemistry in the pharmaceutical industry can offer a real improvement in the quality of life for our ageing population. The move to cleaner economic growth through low-carbon technologies and the efficient use of resources is one of the greatest industrial opportunities of our time. By one estimate, the UK's clean economy could grow at 4 times the rate of GDP. Sustainable chemistry is a quickly expanding area that looks at how chemistry can influence processes and technology that can have a positive impact on the climate emergency. From the aforementioned optimization of reaction conditions using AI to research into carbon capture generated from waste, there are endless fascinating opportunities for chemists to help shape our future. We are on the cusp of a profound change in how we move people, goods, and services around our towns, cities, and countryside. The government has already pledged that petrol and diesel-powered cars will not be sold in the UK after 2030, and the electric and fuel cell-powered car markets are already beginning to boom, and this will only increase. Chemists are integral to the success of this industry in designing and optimizing new and efficient fuel cell technology that will become the standard for transport around the world. Studying a chemistry degree can never be boring. How can it be when every lecture and lab class offers the chance to discover and learn something that you could use to make a difference to our future? Chemistry at university is taught in a number of different ways that may be different to what you've experienced before at school or college. Lectures are the primary method of imparting core knowledge, but these are rarely the stereotypical old white-haired man stood at the front of a lecture theatre with a piece of chalk and a blackboard. No, they are interactive, they use a variety of technologies to help facilitate your learning, and are delivered by lecturers who are enthusiastic about the topic and want you to be too. And hopefully you can see by looking at me that we're certainly not all the white-haired old men that you can see in films as well. These lectures will be supported with a variety of different problem classes and workshops in which you get the chance to put your learning into practice. These are usually in smaller groups so that you get a proper opportunity to take advantage of having us on hand to help. These can take lots of different formats, such as tutorials where you'll complete some questions beforehand and then go through them during the session itself. Workshops where you tackle questions within a timetabled session with staff circulating to help. Or team and problem-based learning where you will work in small groups to solve problems together. An example of this is a drug design exercise that we run with our second-year medicinal chemists. They work in teams as they would in industry and are provided with a lead molecule isolated from a high-throughput screen. They complete iterative rounds of structure optimization, gathering data on the activity and the pharmacokinetic properties of the analogues, to hopefully develop a new and more effective drug candidate. And the students really enjoy sessions like this because it's authentic to what they would have to do in the workplace and how they would have to work with other people to apply the skills that they've learned during their degree. Lab classes are obviously integral to a chemistry degree. You will get to experience a range of different labs and experiments from synthetic to analytical and physical. The picture on the slide shows one of our synthetic chemistry labs. These are usually full of fume hoods, and it will be where you will work to synthesize organic and inorganic compounds. I'm an organic chemist myself, so these kind of labs are where I feel most at home. There's nothing more satisfying than isolating a product you've been working towards as a beautiful, pure crystal. Inorganic synthesis is where you'll make lots of different metal complexes, and these tend to be where you'll see lots of vivid and spectacular colour changes. Analytical and physical labs involve measurements and the use of instrumentation to quantify this. We endeavour to give you an experience of a wide range of instrumentation that you would use in industry so that you're as prepared and ready as possible when you graduate. So what to expect in terms of the course itself? Well, the first year of a chemistry degree is designed to get everybody up to speed with core chemistry knowledge and practical techniques. One question that I regularly get asked by potential applicants on open days is, do I need to be doing A-level maths? Well, the simple answer is no. Whilst A-level maths will certainly be useful, it isn't a prerequisite. So the math skills that are required for chemistry are often covered in the first year of a degree. But these are taught in the context of chemistry to make them much more accessible to chemistry students who haven't studied maths since GCSE, and it allows them to be successful in the later years of the degree. In the second year, the core chemical knowledge taught in first year is expanded into the key areas of organic, inorganic, and physical chemistry. These three disciplines will really begin to take shape and make you start to see how they can be used to solve some of the global challenges that I mentioned before. Rather than lab classes being focused on developing your practical skill set, you'll use these skills to conduct experiments that link closely to the theory you'll be studying. This includes learning to use more challenging, air-sensitive or pyrophobic reagents in synthesis, or more complex instrumentation to study the kinetics of a reaction or determine the identity and composition of trace evidence. The second year is where many universities will allow you to begin to specialise in areas such as medicinal chemistry or radiochemistry or sustainable chemistry. These are topics that directly link to the global challenges and apply core chemistry to real applications. In year 3, you can often further tailor your degree to your favourite modules and areas through optional or elective topics. This can be useful if you have a particular career in mind to help bolster the skills that you need for that. You will also complete an independent research project and dissertation. A dissertation is a literature review of an area of chemistry that you're interested in and will develop your information literacy and your knowledge of a specialist area. Your research project will often be the pinnacle of your degree. You can choose the area of chemistry for your project and again tailor this to where your interests most lie or the industry that you want to go into after your degree. Whenever we ask our graduating students about their favourite moments in their degree, their project and the project labs are always up there near the top. So in a chemistry degree, you can either graduate after 3 years for a bachelor's or a BSc degree in chemistry, or you can continue on for a 4th year to study for an MChem, a master's in chemistry. If you do this, you will study more advanced taught topics, but most of your 4th year will be taken up by an independent research project where you will get to work in an active research lab in your department alongside PhD students and staff. This provides not only a wonderful opportunity to develop your research skills, but also the chance to publish your findings in the scientific literature. The picture here shows a variety of published journal articles with some of our own MChem students' names circled, where they are listed as authors and contributors. Your time at university isn't all about your degree. You'll get lots of opportunities to bolster your CV and life experiences to make you really stand out from the crowd. Different universities offer different opportunities, but most are along the same lines. At Keele, we offer a year in industry where you pause your studies between your 2nd and 3rd year to go out and work in the chemical industry. This is a fantastic opportunity to see how industry works and improve your skills by immersing yourself in working chemistry for a year. Our students that go out on a year in industry always go on to really excel in their 3rd and 4th year research projects, utilising the skills and drive that they learned in industry. There is often the opportunity to study electives such as languages alongside your degree. These again can offer you a significant advantage when applying for jobs if you're looking at joining a global company. With that in mind, some universities offer the chance to study abroad for a year or semester. If it's the whole year, this is usually between the 2nd and 3rd year, and the students that do this at Keele always come back having really grown as a person. Students go on to a whole range of different careers after graduating with a chemistry degree. Those listed on the left are more directly using a chemistry degree to work in a specified industry. So you can stay at university to work as a PhD researcher and progress to be an academic. You can work as a medicinal chemist in the pharmaceutical industry, be a chemical or nuclear engineer, a cosmetic scientist, use your analytical skills to move into forensic science or work as a toxicologist, or look towards the future as an environmental or materials scientist. You can use your chemistry degree to obviously become a chemistry teacher or even work in science communication. Some students decide to move away from chemistry, with some of those careers shown on the right that our graduates have moved into. Careers such as accountancy and management highly value the transferable problem-solving skills and logical thinking approach that chemistry graduates are taught throughout their degree. Thank you very much for listening. I hope I've said some things that have inspired you to consider a future in chemistry. When it comes to your applications, all we want to see is that you are as enthusiastic as we are about using science and chemistry in particular to help shape our future. So again, thank you for listening, and who knows, I may even see you in my lecture theatre in the future.